Hello everyone, welcome back in online learning of microprocessors and microcontroller subject. Subject code is ETC302. In today we are going to discuss on the microprocessor 8085 architecture, pin diagram and addressing modes. This is our video number 4. In last lecture, we have studied the evolution of microprocessor, in which we will see the generations of microprocessor, evolution of microprocessor, their types, advantages and disadvantages of microprocessor. These points we have already studied in the last lecture. Now, from today, in this lecture, we are going to study the architecture of 8085 microprocessor, functional units of 8085, pin diagram of 8085 and addressing modes of 8085. So, we will see one by one. Architecture of 8085. The architecture of 8085 microprocessor provide the idea about what are the operations to be executed and how these are performed. Also, it can perform operations like operates on and store 8-bit data. It executes arithmetic and logical operations. 8085 also sequences the instructions which is to be executed and stores data temporarily. However, in order to perform all such operations, like the processor needs a control unit, arithmetic logic unit, registers, buses, etc. We have already discussed how CU and ALU and buses functions in a microprocessor. Here in this lecture, we will discuss the detailed architecture of 8085 microprocessor and how it is operates. This is the architecture of 8085 microprocessor. This diagram consists of 8-bit internal data bus which is connected to the interrupt control and serial input-output control. Also, it is connected to the accumulator, temperature register, flip-flops, then instruction decoder and machine cycle encoding. Also, 8-bit internal data is going through instruction register, instruction decoder and machine cycle encoding. And finally, going to the timing and control block. Also, 8-bit data bus is connected to the stack pointer, program counter and incrementer and decrementer address latch. This register array is connected to address buffer and address buffer 8-bit. Now, we will see the detailed architecture by functional units of 8085. First is arithmetic and logic unit. This block is used to perform the operations like addition, multiplication, subtraction, division, decrement and increment. Next is flag register. Now, flags register basically holds the status of the current result which is generated by the arithmetic logical unit, and it is not the actually generated result. Thus, we can say that it is the test the data conditions. 8085 has 5 flags that shows 5 different data conditions. These are carried, sign, 0, parity and auxiliary carry flags. However, the mostly used are sign, carry and 0. Flag register is 8-bit register that stores either 0 or either 1. Next block is accumulator. Accumulator is a 8-bit register that stores the result of the operation performed by the arithmetic logic unit. Also, it is known as a register A. Next is general purpose registers. These are nothing but the set of flip-flops. These are basically used to hold and store the data. General purpose registers like 8085 microprocessor contain 6 general purpose registers that are present inside the microprocessor and stores 8-bit data in order to execute a program. These general purpose registers are B, C, D, E, H and L. These registers can be combined to form a pairs like BC, DE and HL in order to execute a 16-bit operation. These programmable registers, that means these registers are accessed by the programmer to insert and transfer the data by making use of instructions, that are temporary registers. Temporary registers is 8-bit registers that holds the operand and provide it to the ALU for program execution. Next one is the program counter. Program counter is basically a special purpose register which is used to share the memory location of the instruction to be performed. As it is clear that in order to fetch an instruction from the memory, the microprocessor needs to know about its address. Without knowing its address, microprocessor does not fetch any condition. It is 16-bit register as it stores address. This register is used by the microprocessor to line up the instructions that are to be executed in a sequential manner. It functions in such a way that it fetches the opcode from one memory location and simultaneously get incremented by the next memory location. Thus, it provides sequencing of the program to be executed. Our next block is stack pointer. It is 16-bit register and this is the part of memory. Data is stored in the stack in serial format and stack pointer generally stores the addresses of the last data element stored in the stack. Stack is based on LIFO, that is LIFO. Whenever new data is added in the stack, then the stack pointer starts pointing towards the next memory location. When a data element is removed from stack, then the stack pointer points a previous occupied memory location. The next one is the temporary register. These registers are used by arithmetic logical unit which is used to store the data on temporary basis, and these registers are not accessed by the programmer. Also, there are two types of registers, that is temporary data registers and W and Z register. In temporary data registers, it is 8-bit register which is used to hold the operand and provide it to the ALU, that is arithmetic logic unit, for program execution. Also, the immediate results are stored by ALU in this register type. Next one is the W and Z registers. These registers are used to hold the temporary values, also used by the control section of the microprocessor, so as to store the data during operations. Next one is the instruction register and decoder. The purpose of instruction register is to shift in instruction through TDI and having the provision to store the instruction till new instruction is fully shifted in. And the next is instruction decoder. Instruction decoder from the instruction register IR is fed to a decoder logic, which selects the data register for JTAG operation. We assign a unique code or value to each and every data register in the JTAG. In order to select data register, we load the IR with the corresponding opcode and the instruction decoder, which decodes the value and establishes an access path between the TDI and TD1 and TD0 and the required data register. Next one is timing and control unit. We use timing and control unit in 8085 for the generation of timing signals and the signals to control. All the operations and functions, both interior and exterior of the microprocessor, are controlled by this unit. Every operation in the entire 8085 system occurs with the given synchronization process with the clock. The next unit is interrupt control. In computing, a programmable interrupt controller is an integrated circuit which helps a microprocessor to handle interrupt requests or coming from multiple different sources which may occur simultaneously. Next one is the address bus and data bus. An address bus is used for the location in determine memory that processor will read data from or write data to the unit. And the data bus contains the contents that have been read from the memory and are to be written into the memory location. Next point is serial input and output control. This unit is designed for the control a peripheral device that is connected to a port on a serial controller, a client application or peripheral device which sends input and output requests to the port. In addition, Windows defines a set of serial input and output control requests that a client can use to configure a serial port. We can say that the main function of the 8085 microprocessor is that includes on a single chip most of the logic circuitry for performing computing tasks and communications with peripherals. This device is used for only this purpose only. Now we will see some applications of the microprocessor. Microprocessor based systems are thus found everywhere today, not in just computers and smartphones, also in automatic testing of products, speed control motors, traffic light control, then communication equipments, television, satellite communication, home appliances such as microwave, oven, washing machine, gaming, etc. Everywhere we can use microprocessor. In the next lecture, we will study the pin diagram of 8085 and the addressing modes of microprocessor 8085. There are 5 modes like direct addressing, register indirect addressing, immediate addressing, and implied addressing. Then these modes we will study in detail in the next lecture. So thank you very much. Have a good day.